Hello students, I am Mr. Adinath Badar, Assistant Professor, Department of Chemistry, late Pushpadevi Patil, Arts and Science College, Risod, Dist, Washim. In this today's video lecture, I am going to discuss topic for B.Sc first year, unit second, S block elements, lecture number first. So firstly, we see the definition of S block elements. Definition of S block elements. The S block elements are those elements which have outermost shell incompletely filled and the last electron is present in the S subshell of the outermost shell. They do not have any electrons in inner d orbital, whereas inner s and inner p orbitals are completely filled. The elements of group first A and group second A of the periodic table constitute or called as S block element. The positions of these elements are lies in periodic table at a left side. For example, or here these are the first A group and these are the second A group having elements in first A group elements. It is also called as alkali metal having elements lithium, sodium, potassium, rubidium, cesium and francium. In second A group, or it is also called alkaline earth elements having elements beryllium, magnesium, calcium, strontium, barium and radium. And radium. These are the S block elements lies at left side in a periodic table. First A group elements called alkali metals element and second A group elements are called alkaline earth metals, and these two group elements are called S block elements, and the last electron enters in S subshell. That's why these elements are called S block elements. Now we see the characteristics properties of S block elements. They have metallic character. They show low electronegativity values. They have basic oxide and hydroxide, or they form basic oxide or hydroxide. They have ionic bond with fixed oxidation state. They show characteristic flame color. They show weak tendency to form a complex. Now firstly we see what is the metallic character. Metallic character, that is, they have a tendency to lose one or more electron to form positive ion or cation. Metallic character of these elements in the group increases as we move from top to bottom. Now next properties are electronegativity. It is the simple ability or capacity to attract shared pair of electron towards itself, that is low nuclear attraction for outer electron, highly electropositive, small electronegativity. These are the some values. Here we see the electronegativity values are decreases from top to bottom. Here lithium shows 1, here sodium shows 0.9, potassium shows 0.8, rubidium 0.8, cesium 0.7, francium also 0.7. That is, as we move from top to bottom, the electronegativity value goes on decreases as the electropositivity or metallic character goes increases as we move from top to bottom. As like first A group elements, second A group elements also shows here beryllium have a value 1.5 of electronegativity, magnesium shows 1.2, calcium shows 1.0, strontium shows 1.0, barium shows 0.9, and radium shows 0.9. Here also the values of electronegativity goes on decreases from top to bottom, and the electropositivity character R goes on increases from top to bottom. Now the next is basic oxide or hydroxide. Here lithium oxide, sodium dioxide, potassium oxide, here cesium oxide, and these are the hydroxide: lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, and these are the oxide of second A group elements: beryllium oxide, magnesium oxide, calcium oxide, strontium oxide, barium oxide, and these are the hydroxide of second A group elements or alkaline earth elements: beryllium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, and barium hydroxide. Now the next are oxide and peroxide and superoxide reaction with water. These are the general reaction. For example, oxide means O2 minus plus H2O to gives hydroxide. Peroxide, this peroxide plus water to gives hydrogen peroxide plus hydroxide. Superoxide, these are twice O2 minus, twice H2O, twice hydroxide plus hydrogen peroxide plus oxygen. Peroxide ion means O2 2 minus. Superoxide means O2 1 minus. Lithium does not form peroxide or superoxide. Now the next are hydroxide. Group first hydroxide, that is we see in the table, that is lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, and cesium hydroxide. All are soluble base strain and increases. The basicity of hydroxide are increases from top to bottom, from lithium to cesium. As we move from lithium to sodium, sodium to potassium, potassium to rubidium, rubidium to cesium, the hydroxide basicity are increases. Now in the group number second hydroxide, we see in the table, that is beryllium hydroxide, magnesium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxide. Solubility increases from amphoteric to basic. Base strength are increases as like first group. In this group also the basicity of hydroxide are increases as we move from top to bottom, from beryllium to magnesium, magnesium to calcium, calcium to strontium, strontium to barium. As we move from top to bottom, the basic character of hydroxide or strength are increases from top to bottom. Now the predominantly ionic with fixed oxidation state. Group first element, or these are the just concept for oxidation state. Group first, most electropositive metals. In the group first, most of the elements are electropositive metal having low first ionization energy and extremely high second ionization energy, from predominantly ionic compound with non-metal by losing one electron. They show +1 oxidation state, means the group first element are prefer to lose one electron to give a cation. We see the example in previous lecture. In ionic compound, sodium always prepare to lose one electron. In group second, electropositive metals, they also show first and second ionization energy but very high third ionization energy, have a fixed oxidation state, or they show the oxidation state that is +2. Beryllium and magnesium compound possesses some degree of covalent character. The group second elements always show +2 oxidation state due to they prefer to loss of 2 electron. They prefer to loss of 2 electron to give a octet, or to attain the octet, or to attain the 8 electron in valence shell. That's why these element, group second element, alkaline earth elements always prefer to lose 2 electron to form a dication, to form a dication. Now the next properties are flame colors. The next properties are flame color. All the alkali and alkaline earth elements are shows a characteristic flame colors. For example, here these are the burner, these are the flame, and this compound shows a different color. For example, lithium shows a deep red color, sodium shows yellow color, potassium shows lilac color, rubidium shows bluish red color, cesium shows blue color. In the group second, calcium shows brick red color, strontium shows blood red color, and barium show apple green color. These are the sample, these are the hydrochloric acid for the test purpose. After these all elements shows flame coloration on flame due to availability of valence shell electron, availability of valence shell electron. Now the next properties is weak tendency to form a complex. So complex are the coordination compound. Complex formation is a common feature of D block elements. All D block elements form a complex with ligand. These are the complex of cobalt, hexaamine, cobalt, third ion. Now some of the S block metal ion have no low energy vacant orbital available for bonding with lone pairs of surrounding ligand. These ammonia ligand, they rarely form a complex. They rarely form a complex but shows a low tendency or weak tendency to form a complex with ligand. Now the next topic is variations in properties of element or comparative study of elements, that is these are the properties: atomic radii, ionization enthalpies or energy, hydration energy, melting point, reaction with oxygen, reaction with water, reaction of hydrogen and chlorine. Another, that is electronic configuration, ionization energy. These all these properties are I am going to discuss in a next lecture. So thank you.